Linear equations in one variable. In this video, let's study today what are linear equations in one variable. Please note that linear equations can be in multiple variables as well. But in this video, we will cover only linear equations which are in one variable. So let's understand now. When the highest power of the variable occurring in the equation is 1, and only one variable is used, such type of equations are called linear equations. For example, x plus 2 equal to 4, 3d equal to 12, 2x plus 3 equal to 9 by 2x plus 5. All these are example of linear equations in one variable. Now let's see some key points of linear equations. Point 1. For any linear equation, there will be a presence of an equal to sign in the equation. Point 2. The quantity on left of the equality sign is called the left-hand side or LHS of the equation, and that on the right side is called the right-hand side or RHS of equation. For example, consider a linear equation x minus 3 equal to 5. Here, x minus 3 is the LHS of the equation and 5 is the RHS of the equation. The values of the expression on the LHS and RHS are equal and become true only for certain values of the variable. These certain values are called the solutions of the equation. For example, for the equation x minus 3 equal to 5, the equation will be true for x equal to 8. That is, for x equal to 8, LHS will be equal to RHS. Hope now you have got a fair idea on linear equations in one variable. Now let's understand how to solve these linear equations in next few minutes. Let's first see what is balancing method. In this method, we can add or subtract the same number on both sides of the equation. Also, we can multiply or divide both sides of the equation by the same non-zero number. If both the sides are in fraction forms, we use the method of cross multiplication. For example, if ax plus b divided by cx plus d is equal to p by q, then it can be written as q multiplied by ax plus b is equal to p multiplied by cx plus d. Now let's see what is transposing method. In this method, any term of an equation may be taken to the other side with a change in its sign. The objective is to move variables to the one side of equation and constants to the other side. For example, 5x plus 7 equal to 2x plus 1. By transposing the terms, we can write this equation as 5x minus 2x equal to 1 minus 7, which result into 3x equal to minus 6, which resolve into x equal to minus 3. Let's understand this via more examples. Let's look at the example 1. In step 1, we have transposed variable to one side and constant on the other side. In step 2, we have solved the RHS by taking the LCM. In step 3, we have balanced the equation by multiplying both the sides by 3 by 2, which gives us the solution as x equal to 2. In step 4, let's look at the example 2 now. Since both the sides are in fraction forms, we will cross multiply first in step 1. Then in step 2, we will open the brackets by multiplying. In step 3, we will transpose our constant and variables, which will lead us to the solution in step 4 and 5, and give us the result, x equal to minus 11 by 9. Hope you got a fair idea now on these linear equations and how these can be solved. Now let's study how we can reduce complex linear equations to simpler form. Let's take an equation example, which is x plus 7 minus 8x by 3 equal to 17 by 6 minus 5x by 2. Firstly, we will transpose 5x by 2 on LHS and 7 to RHS. The result of these steps will be x minus 8x by 3 plus 5x by 2 equal to 17 by 6 minus 7. Now solving this equation by taking LCM on both the side, we will get 5x by 6 equal to minus 25 by 6. and final solution will be x equal to -5. Now let's study application of linear equation in next few minutes. Usually, one will encounter many practical situations where he needs to apply the methods to solve the linear equations. The utility of linear equations lie in their diverse applications. Different problems on numbers, ages, perimeters, combination of currency notes, and so on, can be solved using linear equations. Let us consider an example to understand it. Let's take first example. Sum of two numbers is 70. One of the numbers is 10 more than the other number. What are the numbers? Let's see the solution. Let's assume the two numbers are x and y. Now in first condition, it's given that sum of these two numbers is 70. That means we can write x plus y equal to 70. Further, it is given that one of the number is 10 more than the other. So let y be 10 more than x. Hence y equal to x plus 10. Now in first equation, let's substitute value of y and we will get first equation to be solved as x plus 10 equal to 70. By solving this simple linear equation, we will get x equal to 30. Now from the second equation we can get value of y by replacing value of x. So value of y will come to 40. Hence, the two desired numbers are 30 and 40. Now let's take second example, which is little more complex than first example. There are two conditions in this example. First condition is, the denominator of a rational number is greater than its numerator by 8. And second condition is, if the numerator is increased by 17, and the denominator is decreased by 1, the number obtained is 3/2. So by considering these conditions, we shall find the rational number. Let's try to form the equation first and then solve those. Suppose, the numerator of rational number is x. Hence, its denominator will be x plus 8. Then the rational number will be x by x plus 8. Second given condition is, if the numerator is increased by 17, and the denominator is decreased by 1, the number obtained is 3/2. Thus we get x plus 17 divided by x plus 8 minus 1 and this will be equal to 3/2. This will solve into x plus 17 divided by x plus 7 and this will be equal to 3/2. Now by using balancing method, we will multiply both sides of this equation with 2 into x plus 7. By this way, our equation will be 2 into x plus 17 equal to 3 into x plus 7. By solving this simple linear equation we get the value of x equal to 13. Thus, the rational number will be 13/21. I hope you have understood what are linear equations in one variable and how to apply and solve them easily. Happy learning, students!